When a system needs to resolve a domain, it doesn't just shoot off a query into the void. There's a method to the madness. Firstly, it checks its own client cache. Think of this as like the system's short-term memory. If the domain isn't there, it sends a query to the DNS server, which then checks its server cache. Bit of like its own quick reference. If it's still drawing a blank, the server checks to see if it's authoritative for that domain or it hosts it. If so, it looks at its zone and returns a record. If not, it then forwards that request onto its configured forwarders or the root hints that it has. Only after these steps is a response formulated and sent back. Caching is crucial here. It significantly reduces DNS query times by eliminating the need for repetitive lookups. For sysadmins, understanding and managing these caches can drastically improve network performance and troubleshoot DNS issues. In this quick demo, we'll unravel the magic behind DNS client-side resolution. We'll begin by peeking into our current cache, proceed to resolve a domain while bypassing the cache, and then verify our cache's contents. We'll finish by clearing the client-side cache. Let's dive right into understanding how DNS resolution works from the client side. We'll use PowerShell to inspect and manage the DNS client cache and simulate the entire DNS resolution process. So first, I want to show you what's currently in the client cache. So I can run the get DNS client cache commandlet on any Windows machine to easily see the client cache. And it looks like right now, it has resolved the SRV1 name in the past. So to start from scratch, let me clear the DNS client cache with the clear DNS client cache command. Imagine you have a host, let's say example.ps4sysadmins.local. Let's see how the client goes about resolving it. To ensure we're really seeing the process, I will skip the client cache for now. I can skip the client cache by using the DNS only switch here on the resolve DNS name command. This completely skips the cache and then just goes directly to querying whatever DNS server this machine has set up. Let me check the cache again. And now you can see that it has added the 10.0.0.4 or the ps4sysadmins.local record. Let's test the speed when using a cache versus not using a cache. To do that, first, I will clear the client cache again to make sure there's not anything in there. Let me check that again. Yep, nothing in there. And I will time both methods. And I can do that by wrapping the resolve DNS name command inference into a script block and using the measure command to measure how long it takes for this operation to happen. Okay, now that that's done, let's check and see how much time it took. And it took around 3 milliseconds. Okay, well, that's not too bad. Now that the record is in the cache, let me make sure that it actually is in the cache. Yes, it's in there. Now I'll run resolve DNS name again, and this time it should query from the local cache. And now we can check the time using the cache. And you can see that it's still 3 milliseconds. The tick's 37.37405, and the tick is 39886. We did shave off a little bit of time. This comes into play, especially when you have lots of DNS queries. So for example, when you're browsing a website and you query dozens of names, this cache significantly speeds things. Understanding the DNS client-side resolution process here helps you troubleshoot faster, and knowing how to quickly perform tasks like this with PowerShell is a feather in your cap. For this demo, we'll journey through the inner workings of DNS server caching. We'll start fresh by clearing our server cache, then we'll resolve an external domain such as google.com. As we delve deeper, we'll measure the resolution time, first by bypassing the cache and utilizing it, and we'll observe closely how caching greatly enhances the speed of our DNS resolution. Jumping into the server side of things, DNS server caching plays a pivotal role in efficient name resolution. Using PowerShell, let's delve deep into how a DNS server handles queries, checks its cache, and interacts with its zones. So to start off with, let's ensure we're dealing with a clean slate here by clearing the DNS server cache. And if you couldn't tell already, I'm remoted into my SRV2 server, which is a DNS server on my network. Clearing the DNS server cache just requires running clear DNS server cache and confirming, yes, we want to clear all the cache records, and all the cache records should be gone on SRV server 2 now. So let's check and see. Now we can do show DNS server cache. And now you can see that there are still some there. Now you'll always see a set of records like this in the server cache. Since it's hosting a zone, some records will always be in there. And also, since it's using root hints, you will also see all of the A-B-C-, etc., all the root-servers.net. Those will always be in the server cache as well. Now let's simulate a client and try to resolve a record now that's not in the cache, that's external to the DNS server. And you notice here that I am using the server parameter specifying SRV2 even though I am on the SRV2 server. That's because the way that my network is configured, the SRV2 server's NIC has SRV1 to it. So I need to specify SRV2 to make sure that I'm being querying SRV2 as a client. All right, now that looks like a successful google.com query has happened. Now let's look at the DNS server cache again. Scrolling up here a little bit, and now you can see all of the google.com records that have been cached. Now, for the fun part, let's time the DNS server in action like we did the clients. So first, I'll measure how long it takes to resolve the domain when it's not using the server cache. So I will clear it first to make sure we have a clean slate. And time it when I'm not using the cache, using the DNS only switch. And now it should be cached. Now let's time it when the google.com records are in the cache. And now we compare. Looks like it took a whopping 11 seconds to do that query when it was not in the cache. And the time in the cache looks like we're down to 17 milliseconds. So you can see that there is a significant difference at the server cache level when there is already a record in the cache. That way it doesn't have to reach out to an external DNS server.